Hello everyone, welcome back to my channel. In the last video, I have introduced you this IBM Q online quantum computing platform, and I have also introduced you some qubit gates. So in this video, I will show you hands-on how to operate this quantum computing platform, how to do experiment on it. So Google IBM Quantum Computer or IBM Q, and you will be directed to this official website, and then scroll down and try IBM Q experience and try it out now. So I have already logged in. If you have not logged in or you didn't have an account, you can log in with your Google account or something else, and you can also register with email. So everything is free. Yeah, so once you are logged in, you will see this window on the right hand side. Those are the backends. Yeah, but basically those are the quantum computers that you can use. You notice that this simulator is just a simulator using classical computer. Yeah, so this is not a real quantum measurement. For all of the others, they are really quantum computers, and 14 qubits, 5 qubits, 5 qubits, and you will see that how many jobs are there before you in the queue. Yeah, so you see that this is 159 jobs, so you'd better not use that. Yeah? In our case, we will just use the 14 qubits Melbourne one. Here, those are the recent circuits, the recent files that you write, and those are the results. On the left hand side, those are the menu. If you move your mouse there, it will expand to the details. And for example, those are the results. And for us, it's important to go to the circuit composer. So this is the place that you can construct your circuit. Yeah? Okay, so we add a new circuit. We can change the name of the experiment to be, here, text. Yeah, test 1. And you save the changes pressing here to save the change. Now we have 5 qubits here. Yeah, those lines are qubits. And on the left hand side, you can also find help and also settings, and you can also click here. That's the circuit editor. And those are the so this is the language that I talked about, this QSKit. The left hand side and the right hand side, they are equivalent. If you drag some gate here, it will automatically add a line there. Yeah, or you can also write lines directly. But I find this visual programming like easier to understand, because this is also the common language of the quantum computing field. Yeah, so if you want to remove it, you can click on it and cancel this. We have 5 qubits. What we can do is that we can directly add a measurement here. Yeah, so the first qubit, it is initialized to 0, and if we do the measurement, we expect to see 0. Yeah, so what we can do is that we can save changes and run the experiment. It takes some time. Okay, so it is saved and then run. We don't want to run it on a simulator because that is boring. Let's run it on this 16 qubit machine. And you also need to select how many numbers of experiment you want to run, because this is a quantum measurement, so so it is probabilistic. So let's say 4,000 measurements, and then run. So it was sent to the quantum computer, and one way to check it is to go to the results here, and another way to check is to scroll down, and then see in the pending results and results. Yeah. So now it seems that it has been completed, and we click on the result, and yeah, so basically those are the runtime statistics. And here you can see that 99.536% shows 0. Yeah, only 0.46% shows 1. All of the other qubits are 0 because there is no operation on it. Okay, so this is more or less expected because we initialized the qubit to be 0. So if we measure, it should be 0. But of course there is some error, there could be some decoherence which result in this error. Okay, so in this video I have shown you how to use and how to do experiment on this simple IBM Q platform, and in the next video we will actually add some gate on the circuit and then see what's the result. Okay, thank you for watching and I hope to see you next time.